Ground fault circuit interrupters, GFCIs, are safety devices designed to protect against electrical shocks. They achieve this by detecting imbalances in the electrical current flowing through a circuit. A two-pole GFCI breaker is specifically designed for 240-volt circuits. It has two poles, each connected to one line of the 240-volt supply. The fundamental principle of operation relies on monitoring the current balance between these two lines. Under normal conditions, the current flowing through each line should be equal. The GFCI breaker remains closed, allowing power to flow to the connected appliance, in this case a jacuzzi. However, if a ground fault occurs, an imbalance arises in the current flowing through the two lines. A ground fault signifies that some of the current is leaking to ground, potentially through a person touching a faulty appliance. The GFCI breaker is designed to detect this imbalance and react quickly. When the current difference between the two lines exceeds a certain threshold, typically around 5 mA, the GFCI breaker trips. Tripping the breaker instantly cuts off power to the circuit, preventing a potentially fatal electrical shock. Jacuzzis typically operate on 240 volts and require two lines of electrical current for their operation. Therefore, a two-pole GFCI breaker is essential for providing proper electrical safety. The GFCI breaker is installed in the electrical panel, and the two lines of current from the jacuzzi are connected to it. This configuration ensures that the entire jacuzzi circuit is protected against ground faults. If a ground fault occurs within the jacuzzi, such as current leaking to the jacuzzi's frame or water, the two-pole GFCI breaker will trip, immediately disconnecting power and preventing electrical shock. The use of a two-pole GFCI breaker is crucial because standard circuit breakers only offer protection against overloads and short circuits. Overloads occur when the circuit draws more current than it is designed to handle, while short circuits involve a low resistance path that causes a large current flow. While these conditions can be dangerous, they don't necessarily protect against ground faults, where current leaks to ground. Ground faults can occur even when the circuit is not overloaded or short-circuited, making them particularly insidious. GFCIs, including two-pole GFCIs, provide an additional layer of protection by specifically detecting these ground faults and tripping the breaker accordingly. When selecting a GFCI breaker for a jacuzzi, there are a few important considerations. Firstly, the GFCI breaker must be rated for the amperage required by the jacuzzi. This information can typically be found on the jacuzzi's nameplate or in its instruction manual. Common amperage ratings for jacuzzi GFCI breakers are 30 amps or 40 amps. Secondly, the GFCI breaker should be installed by a qualified electrician. Proper wiring and functionality are crucial for ensuring that the GFCI breaker operates correctly and provides adequate protection. A correct installation can render the GFCI breaker ineffective, leaving the jacuzzi user vulnerable to electrical shock. Thirdly, it is important to regularly test the GFCI breaker to ensure it is functioning correctly. Most GFCIs have a test button that can be pressed to simulate a ground fault and trip the breaker. This test should be performed at least once a month to verify that the GFCI breaker is working properly. If the GFCI breaker does not trip when the test button is pressed, it should be replaced immediately. In summary, a two-pole GFCI breaker is a vital safety device for any 240-volt jacuzzi. It provides protection against electrical shocks by detecting ground faults and quickly cutting off power to the circuit. When selecting and installing a GFCI breaker, it is important to consider the amperage rating, ensure proper installation by a qualified electrician, and regularly test the breaker to verify its functionality. The 2008 National Electrical Code, or NEC, provides guidelines for electrical installations, including the use of GFCI protection. While the exact requirements may vary depending on the specific application and local codes, the NEC generally mandates GFCI protection for outlets and circuits located in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Specifically, Section 680.42 of the NEC addresses the requirements for spas and hot tubs, which includes jacuzzis. This section mandates GFCI protection for the electrical circuits supplying power to these appliances. The specific requirements for GFCI protection may vary depending on the voltage and amperage of the circuit, as well as the location of the spot or hot tub. In general, the NEC requires that all 120 volts and 240 volts receptacles located within a certain distance of a spot or hot tub be GFCI protected. Additionally, the NEC may require GFCI protection for the branch circuit supplying power to the spot or hot tub itself. It is important to consult the latest edition of the NEC and any applicable local codes to ensure compliance with the specific requirements for GFCI protection in your area. The NEC also provides guidance on the proper installation and testing of GFCI devices. Section 110.3 B of the NEC requires that all electrical equipment be installed and used in accordance with the manufacturer's instructions. This includes GFCI breakers, which should be installed and wired according to the manufacturer's specifications. Additionally, Section 210.8 of the NEC requires that GFCI devices be tested regularly to ensure they are functioning properly. The NEC recommends that GFCI devices be tested at least once a month by pressing the test button on the device. If the GFCI device does not trip when the test button is pressed, it should be replaced immediately. In addition to the NEC, there may be other applicable standards and regulations that govern the installation and use of GFCI devices. For example, Underwriters Laboratories, or UL, is a recognized testing laboratory that develops safety standards for electrical equipment. UL Standard 943 covers GFCI devices and specifies the performance requirements that these devices must meet in order to be listed and labeled by UL. Compliance with UL standards can provide assurance that a GFCI device has been tested and meets certain safety requirements. It is important to note that the information provided here is for general guidance only and should not be considered a substitute for professional advice. If you have any questions or concerns about the installation or use of GFCI devices, it is always best to consult with a qualified electrician. In addition to protecting against electrical shock, GFCI breakers can also help to prevent damage to electrical equipment. When a ground fault occurs, the flow of current to ground can create a path of high resistance, which can generate heat. This heat can damage electrical wiring, insulation, and other components, potentially leading to a fire. By quickly interrupting the flow of current to ground, GFCI breakers can help to prevent this damage and reduce the risk of fire. GFCI breakers are available in a variety of different types and configurations. Single-pole GFCI breakers are designed for use in 120-volt circuits, while two-pole GFCI breakers are designed for use in 240-volt circuits. GFCI receptacles are designed to be installed in place of standard electrical outlets and provide GFCI protection at the point of use. Portable GFCI devices are designed to be plugged into standard electrical outlets and provide GFCI protection for tools and appliances that are plugged into the device. When selecting a GFCI device, it is important to choose one that is appropriate for the specific application and meets all applicable safety standards. It is also important to follow the manufacturer's instructions for installation and use. Proper installation and maintenance are essential for ensuring that GFCI devices provide reliable protection against electrical shock and other hazards. In addition to the test button, there are other methods that can be used to test GFCI devices. A GFCI tester is a device that is designed to simulate a ground fault and verify that the GFCI device is tripping properly. These testers are available at most hardware stores and electrical supply stores. To use a GFCI tester, simply plug it into the GFCI protected outlet and press the test button on the tester. If the GFCI device trips, the tester will indicate that the device is working properly. If the GFCI device does not trip, the tester will indicate that the device is not working properly and needs to be replaced. Another method for testing GFCI devices is to use a multimeter. A multimeter is a device that can measure voltage, current, and resistance. To use a multimeter to test the GFCI device, first turn off the power to the circuit. Then, disconnect the hot and neutral wires from the GFCI device. Next, set the multimeter to measure resistance and connect the probes to the hot and ground wires. If the multimeter reads a low resistance, this indicates that there is a ground fault in the circuit. If the multimeter reads a high resistance, this indicates that there is no ground fault in the circuit. Finally, reconnect the hot and neutral wires to the GFCI device and turn the power back on. If the GFCI device trips, this indicates that the device is working properly. If the GFCI device does not trip, this indicates that the device is not working properly and needs to be replaced. The cost of a 2-pole GFCI breaker can vary depending on the brand, amperage rating, and features of the device. In general, 2-pole GFCI breakers are more expensive than standard circuit breakers, but the added protection they provide is well worth the cost. When purchasing a 2-pole GFCI breaker, it is important to choose a reputable brand and ensure that the device is UL listed. UL listing indicates that the device has been tested and meets certain safety standards. It is also important to choose a GFCI breaker that is rated for the appropriate amperage for the circuit it will be protecting. Using a GFCI breaker that is rated for too low of an amperage can cause the breaker to trip unnecessarily, while using a GFCI breaker that is rated for too high of an amperage can reduce the level of protection provided. In addition to the initial cost of the GFCI breaker, there may also be costs associated with installation. If you are not comfortable installing the GFCI breaker yourself, it is best to hire a qualified electrician to do the work. A qualified electrician will be able to ensure that the GFCI breaker is installed properly and that the circuit is wired correctly. The information provided here is for general guidance only and should not be considered a substitute for professional advice. If you have any questions or concerns about the installation or use of GFCI devices, it is always best to consult with a qualified electrician.